Welcome back to the video classes of the Information System course. In this class we will talk about the typical architecture and the typical infrastructures that lie behind any kind of information system that you should interact with as of today. We are talking in fact about web information systems. So we can start from the definition of a web information system, or WIS. Basically, a web information system is an information system where you have a communication among several devices that are connected on the internet network, or an alternative to devices connected to the real internet. You also have the possibility of devices connected through what is called a VPN. You may have any experience about the utilization of VPNs for various purposes, but in general any VPN, especially in corporate VPNs, consists in having a ciphered channel that is deployed on the internet, which kind of simulates a private connection inside a single company. So basically you send packages over the real internet, but you treat these packages as they are coming from within the borders of an organization. VPNs can be used for security reasons and for providing a secure access to information systems that have to be used in a single company. In general, regardless of how we are connected to the information system, you access to these features, to this data that is dealt with inside the information system through a standard interface, which is the browser. Of course, we can have a browser on my laptop, or I can have, as of today, also mobile browsers, and actually there is a browser on any kind of device that you can think of. There are many actors that can interact inside a web information system. So in general we can have companies. Of course, we can start with the company who creates the information system and or where I am using the information system. Of course, we can have users that are the users to which this information system is presented, to which the information system offers features. We can have also public administration. So this is not the admin of the information system, but we are talking about, let's say, government or administration of the state, or any kind of over administration that is outside the company. Based on these types of actors that can be interested in an information system, we have different types of communications, as you may well know already. And of course we have business-to-business communication, which is the possibility offered by an information system to make possible the communication between different companies. We have also the B2C communication, which means the possibility of a company of interacting with the users through the information system. And of course we also have the possible interaction through an information system with the government or with the public administrations, with this G2B, meaning government to business, and G2C, meaning government to consumer, government to customer. In general, when I talk about web information system, I will have several different information systems, several different types of information systems that will allow some or all of these communications. In general, an information system, a web information system, can have several different layers of complexity. The easiest ones are the so-called informative sites. So, for instance, you have a new company, you have a new startup, and you just create a website where you write down who you are, what are your services, what are your products, what are your contacts. This kind of a landing page, so or a blog, or a journal page, or maybe a newsletter. But in general, the simplest thing that I can create, and you can have, you can dirty your hands and create an informative site in a few hours, even if you don't have any kind of computer engineering competencies. The simplest thing that you can have is an informative website where you just prompt some information about your company. The second step that you can have, so when, for instance, you create a Shopify or an Etsy web page, is when you create an ordering site. So in this case, you have all the features about the selection of something that you want to buy, the basket management, the configuration, the purchases, and whatever. In this case, you have typically connections with the payment systems like PayPal and so on. We can go further in complexity and we can get to the management systems. And typically management systems are used inside companies to govern the way the business is carried out in such company. We have many different types of management systems that we will see in detail in another class, but in general we can have CRM, which are customer relationship management systems that are used to manage the customers, so providing support, providing after-sale support, and so on. We can have SCM information system or supply chain management information system, which allow me to support the supply chain, so the orders that I can make to my suppliers and so on. We have our ERP or Enterprise Resource Planning Information Systems, where I can manage all the resources of a company from the factory, from the manufacturing moment to the sales, so all the resources, all the people inside the company. And we can have the MRP, Manufacturing Resource Planning, that are information systems that are specifically related to managing the resources in the manufacturing activities. You have the docs over there, meaning that it is not just these 4 types, but there are tens of different types of management systems that you can adopt and buy in your companies to perform some operation. If we step up in complexity, we can get to the autonomous systems, and those are the ones where we have money, real money going around, and basically we can have autonomous information system that monitor stuff like actions, for instance, or transactions, finance stuff, and basically they can manage automatically this type of information and perform actions based on that. Of course, we have a last level of complexity for information system, which is the one related to portals, marketplaces, and market spaces, which are different terms that allow to identify information systems that aggregate many different systems inside and make them work together with a unique view to the final users. Of course, there are many vendors of this kind of platforms like SAP, for instance, that provide portals that integrate all the management systems that we had at level 3. Or, for instance, you can think of commercial portals like Amazon or whatever, where you have tens of different functions all combined together in a single information system. So, what we are interested on is not having a complete and profound technological competence about the web information system, but we want to have a kind of a primer, some fundamental concepts that allow us to understand how the web architecture work. In general, and this is just a screenshot, or is pretty old screenshot about the evolution of the web. So, as you can see, if we start from the very beginning, when the HTTP protocol appeared, and in the 90s, some web browsers like Netscape and Opera and Internet Explorer, the good old one, appeared. After that spawn in technology, the situation kinda exploded with the definition and evolution of many different technologies. Let's say each line in this kind of octopus is a new technology that has sparked at some time and that has evolved over time until its end, let's say. And so you can see that there are many different technologies that have been developed over time. We can start from the very beginning by considering the fact that the web is based generally from the very beginning on a tiered architecture. So every level in this tiered architecture has a specific function, a specific role. And with this specific role, each level interacts with all the other levels, all the other layers if you want, exchanging information. The highest level we have our client, the browser client, that is the software with which the final user interacts. If we go down, we have the internet infrastructure, that is all the infrastructure that all of my data to go around in the internet to reach the web servers. The web server is the element, the server, that speaks a standard protocol that allow to exchange information and data with the client. So I will have an exchange of data between the client and the web server, which is made possible by the internet infrastructure. The web server alone is just an element that exchanges data, and it is not capable of providing a lot of features. To do so, we will need the so-called application servers. They are other servers that provide more complex operations. The application servers, for instance, allow to activate operations specific for the information system, like in our examples, activate a internship, so it will be an application working on the application server, and the web server will be in charge of exchanging information with the client. Only that. If we go even lower in the pyramid, we can consider a last level, which is the level of the instruments that are used by the application server. The simplest case is the database server, which helps in memorizing data in a permanent way. In more complex cases, I will have third-party services, other servers to which the application server can request services. Here I will have all my support actors. So the third-party service, for instance, for authentication, or the third-party service, for instance, for payment. The secondary actors lie there. In general, in the base architecture of the web, we have a client, which is the stuff with which my user interacts, and the server, which is providing data and information, and they talk to each other through internet. Typically, the client is a browser, but nowadays the client can also be a mobile application, a desktop application, or any kind of other server application that uses the web server to get some data. There are many components that we have to consider in this architecture that take part in this exchange of data. First of all, we have, of course, we cannot make without of our Internet Service Provider or ISP. In general, the Internet Service Provider is a company that is able to bring an internet connection to the company or to the final customer, to the final user. Like any kind of commercial operator that you have around, like Vodafone, Fastweb, and whatever. All of them are ISP. In general, we don't care about how these companies perform their work with fiber, with connections and infrastructures and whatever. The only thing, everything is transparent to me. I only need to have an internet connection to provide my services. Then, of course, we will need to create a web architecture. We need one or more service to implement all the levels of the architecture. And we will need, of course, physical networks and network devices to make everything work, to make the information flow over the internet. I also need a so-called communication protocol, because at least I need to know a communication protocol. Because the communication in the internet or in networks in general, because internet is just one of the possible networks that you can have, all the communication will happen through communication protocols. A communication protocol is a set of rules to transfer data, to transfer information between two or more peers. The protocol will define the syntax, so the way the data are structured, for instance, the number of bits that you use for an address, the number of bits that you use to identify the type of information that you want to send, and so on and so forth. The protocol will define all the semantics for all the type of data that we have, so what is right and what is wrong, and the procedure that you have to perform. So each communication with a protocol, and we will see one specific protocol later, it is not some kind of random exchange of messages, but you have to perform a complex and predefined set of information exchange to make the communication possible. Of course, I will need the synchronization mechanisms because the communication between the elements on the internet and on any network will be governed by a strict turn-based communication, so I will need to synchronize all the messages that I exchange. And I also will need mechanisms to solve possible errors in the communication. If you think that you have a down in your communication, you need to solve missing data that are there. In general, we said that we need communication protocols, and when we deal with the internet, we have many different protocols. In this slide, you see one protocol stack, which is called the TCP/IP stack, from the names of the most important protocols that are, in fact, TCP and IP. So there are many different protocols, many different layers of communication, and all of them are required to provide a communication between two different nodes, two different peers in the network. So we can start from the lowest level, so going down. This is the upper part of the protocol. While we go down in our network protocol stack, we go to the most simple, to the simplest types of communications, the simplest protocols. At the base level, we have the very simple communication that is the physical communication that is made through radio waves or cables. So we have all the protocols for communication like Wi-Fi, Ethernet, Bluetooth, 4G, 5G, through cellular network. All of them are very simple protocols who just transfer data, bytes of information. Those protocols allow me to send data to another node in the network. The issue is that when I am using Wi-Fi, for instance, I don't want to send the data just to the router that I have in my hall, in my home, but I want to send this information to a server, which for instance is at Polito. So I will need some instruments to transfer the data through a network, to make this information, this data flow through a network. This tool, this communication protocol, will be the IP protocol. And typically, you may well know that every node in a network, every node in the internet has an IP address to identify it, which is like my address of residence. The IP address will be used by the IP protocol to identify one node in the network and send the data to it. The IP protocol is anyway a very simple, still simple protocol, which sends packages of fixed dimension and without any security. Of course, you know that when you send data over the internet, if, for instance, if you send an image or a video or a voice registration, of course, all this information doesn't have a fixed dimension. So there is another protocol which is called TCP, which manages the IP packets, who are all of the same size, and collects them into variable length communication. In addition to that, TCP also provides security guarantees and also provides mechanisms to deal with the certainty that the data has arrived. EP is like non-guaranteed mail, like regular mail. You just send some data and you forget about it. TCP instead allows you to understand if the server, if the other peer actually received your data. Finally, we have two other protocols, which are HTTP and HTTPS, that are used by the browser typically, and that allow to structure the data. So in general, TCP exchanges data, so data streams, and HTTP is in charge of organizing the data. So to structure the data into a web page that then is shown in a browser. HTTPS is the secure version of HTTP with security mechanisms to avoid any kind of security breakout that can provide harm or damage to the customers or companies. Getting back to the type of components that we have in our network architecture, so to continue this discussion about the main components of a network architecture, we talked about servers, and it is important to make a distinction between logical and physical servers, because we can omit this adjective and use the term server to say two different things. A logical server is a program or a software which is executed on a machine using communication protocols like HTTP and all the lower ones. So it is a software. The physical server is a machine. It is a metal box which executes instruction, including the logical server. So typically the physical server is a computer where you install a logical server. In general, since we are not talking about hardware and physical aspects, in all this class and the next ones we will talk about, when we say the word server, we will talk about logical servers. So programs that use some communication protocols and are deployed on an hardware which we don't care about. The main type of server that we will talk about is the HTTP server, so an application which uses the HTTP protocol, which is also called web server. Web server, so will be able to manage the communication through HTTP. And what does a web server do? It receives client requests in HTTP. It reads all the data that has been required by the client, possibly using an application server for getting more data or performing operations, and then it sends back files to the client. Typically, these content that are provided to the user are HTML files. The HTML files will say me how to format my web page on my browser. In general, I have for each request performed to my server, I have an HTTP connection. So every time I perform a request, I will create an HTTP request to the server, and the server will send me back my results to my request, and then if I do another request as a user, I will perform other requests, other HTTP requests. Of course, if we remember the layer, every HTTP request is based on all the chain of layers that we have seen before. So HTTP will use TCP, TCP will use IP, and IP will use the lower level communication. Of course, since if I create a server, I am not allowing a single user to use my applications, of course, the server will be multi-process applications, so they will be able to manage multiple connections in parallel at the same time. So normally a client connects through the internet. Here I have my internet service provider that may cover all the whole world, and in general will make me connected to the internet of the whole world. And the client through the internet will connect to a web server. In addition to the web server, I may have additional servers for specific purposes. So I can have authentication servers, I can have transaction servers, I can have database servers. All of these are the application servers that we have seen before. But how does the communication happen? So the starting point is in the client, in the browser. I type down a URL. The URL is the uniform resource locator. It's the stuff that you type in your address box in your browser. So the client sends an HTTP request, so this one, to the server that is written inside the URL. So the URL is in charge of identifying a server in the internet. The request for something is written in an HTTP request and is sent to the web server. The server receives this request and finds inside the request the so-called path. The path is the address inside the server this time of some resource. So the path allows me to get some resource inside the web server, for instance an HTML file. So the server takes this HTML file on his disk or on a database and constructs its response to the client. So at this point on the server, I can send the response to the client. How do I send back this response? I send back the response through the HTTP protocol again. So I package an HTTP response, including my HTML content, and I send it back to the client. At this point, the client can receive the response. In the response, it can find the HTML content that it wanted, And so this HTML content can be displayed in the browser. Of course, we need to consider that again the request and the response in HTTP is happen inside the context of a TCP connection, which itself is based on an IP connection, which again is based on some network connection. So in the IP connection, I will send packets over the network. In the TCP, I will ensure security, and with the HTTP, I will be able to perform requests and responses. The content that I exchange through HTTP will be an HTML web page that I will display in my browser. Here, of course, I have listed some concepts that are very important and that are standards that are used in any kind of network communication. First of all, we have the URL, which are the locators that I use as addresses for the resources that I can find. Then I have HTTP, which is the protocol that tells me how client and server can interact and which fields of information have to be sent. And we have also mentioned HTML, which is a hypertext markup language, which is a language that allows me to describe the content of a web page with its titles, tables, images, links, and whatever. We will see it later. First of all, we can see how a URL is made. So in a URL there are many different components. So this is a simple example, but in general there are many different components in a URL that can be used, and they are all described in the standard RFC 2396, this one, if you really need to find all the possible information about a URL. So we can see an example here. In the first part of a URL, you have the protocol that you are using. So every time you write down into your address box http http:// you are asking for a specific protocol to utilize to solve that address. This protocol can be HTTP or HTTPS that are the most widespread, but there are other ones like FTP or whatever, SCP, that you can use to access data on remote computers. In general, in a browser, you will always use HTTP or HTTPS. This part, the colon and / is just to separate the protocol from the first part of the URL. The first part of the URL is the host. This stuff here is the name of the server containing the resource that I want to find. So softbank.polito.it or www.google.it will be the name of the server where I want to find a resource. Then I have another slash, and here this part after the server name, I have my resource. The resource can be anything. It can be an HTML file, it can be an image, it can be whatever type of file that you can request to a server. This part here is called URI, Uniform Resource Locator. This part here is like is structured, as you can see, as a file in a file system. Like when you open your file system, you have c/documents/whatever.png. This is the same for a server. So this part here tells me that after I get to this server, I have to search inside the server the file which is in the folder viq and its name index.html. When I have this type of URL, I have to translate this in a request to a specific node in the network so that I can find it in the internet. So I take the instrument that I use is the so-called DNS or domain name service. It appears here. So when I write down softbank.polito.it, this is just a name with letters and words that is easy to use for humans. But when I have to contact a node on the internet, I need to use numbers, because my IP has my IP address is made of numbers, of 4 different integer numbers separated by dots. To translate the readable name, the readable URL, to a set of numbers that can be read by routers and machines, I will use the DNS servers. So the DNS service, which is managed by the Internet Service Provider or ISP, will be able to take softbank.polito.it and find the corresponding address: 130, 192, 173. This is the IP address that will be used to perform the connection. The connection will be at this point be performed by a TCP connection which will contact the server directly. Inside the server, I will have a mechanism that takes this resource name and will translate it in some way which is defined by the web server in the real address of a file, of a physical file, inside the file system. This file will then be taken from the server and sent back to the user. And here we see some examples of complete URL that, as you can see, can contain way more information than just the name of the server and the name of the file that I want to get, because I can get I can have many different information, like the user that I am representing. I can perform directly queries to the database. I can go to a specific section of a web page, and so on and so forth. In general, if I want to see a very high-level example of the whole HTTP protocol, what happens is that my browser will create a HTTP request. When I want to get some data from one web page, I will use this get command. So in the syntax of the HTTP protocol, I will use get queries, get commands to ask my server some data. So the get translates to give me the content of some resources, please. You see that here I report the URI. In this case, I don't report the server address because the HTTP request is contained inside a TCP connection to the server, which has been already identified. In the HTTP request, I write down the version of the HTTP that I am referring to. This is a pretty old example. I indicate the type of content that I am wanting to receive. In this case, I want to receive HTML textual content and also possibly images. And I indicate the type of browser that I am using, because it is possible that the servers will provide different content based on the browser that is asking. Once I receive the request from the server, I package my answer inside another HTTP communication. So I write down the version of the protocol again, and also I write down the type of response. I send a so-called response code. This response code, the good news is represented by the response code 200 OK. For each code, I have a number, which is the code machine readable, and also a humanly readable explanation of such code. In this case, OK. It means that the resource is available and I'm sending it back. I can have other codes. You of course know, because of all the internet jokes, the 404 code, which means unavailable, or even 500 like internal server errors and so on. So the first row is the most important because it tells me if the server found what I wanted. In addition to that, I can provide the date of response, I can provide the type of server which is responding, I can provide information about the last time I modified this resource, the type of content that I am providing, and the content in bytes, that the size of the content in bytes. Finally, I have the content of my HTML file. So I have a lot of information about the file that I'm sending back, and then I actually send the file back to the client. And so you can find all these details. For instance, if you open your developer tools in the browser by pressing F12, you can see that every time you open a web page with any click on your application, on your web application, you will forward this type of HTTP request to a server, and the server will answer you with an HTTP response. And you will find all this information that we have seen here in every operation, every click that you perform on your browser. To measure the quality of a web information system, and if you remember we talked some classes ago about non-functional requirements, there are many measures that can be used, many metrics that can be used to measure this exchange between client and server. One of the easiest one is the latency. The latency is defined as the time that is necessary to provide a 0-byte content, meaning that I suppose that I want to send back an empty content. So if I send back an empty content with my server, I am just sending this stuff here, just the header. It is the minimum amount of information that I can send back. So the latency symbolizes the time that is necessary to send back the minimum possible HTTP answer to a request. It is of course a lower estimate of any type of communication that I can have with my server. So it tells me how fast is a server to respond to my request. And the unit of measure is the number of HTTP response that I can provide in a second. I can also measure the band or the throughput, which tells me the maximum speed with which I can send information. This does not depend on the server because the latency is depending on the server, but the throughput depends on the ISP, on the network through which the server is sending information. And here you can find your the very popular bytes per second. That is the typical way you identify the performance of a network, like a fiber connection which is going at 1 gigabyte per second, for instance. Of course, through the latency and the throughput, I am able to compute the delay, which is the delay, the time that from my browser side, from my client side, I need to wait before receiving my content. The delay is provided by the latency, so the minimum time that you need for getting an HTTP response from the server, plus the size of the content that I need, divided by the bandwidth, the throughput. So, for instance, if I have a latency of 100 milliseconds, this will be always there, because it is the minimum that I need to get a response from my server. Then, the size of my content appears here, and the throughput is how fast I can send this content of 100 kilobytes, for instance. I divide the size of my content by the bandwidth that I am using. This will be a variable part that is depending on the size of the content that I am asking. Of course, you know that if you ask just a simple text web page, it will be faster than asking for the download of a recorded class, because of course this component, which is variable, will be bigger, will be a bigger time for a bigger component, for a bigger piece of information that you want to find. On the other hand, the latency is fixed. It will be the same even if you just want 1 byte, just one blank web page. This is a delay of the server and you cannot make without. In general, every web transaction, this latency, so this fixed component here, is can be split in multiple different times. So the first time is the browser time. The browser receives my request here, where I have this arrow, and it has to elaborate the request. So the browser creates an HTTP request that has to be sent to the server between time t0 and t1. Then I have between t1 and t2, I have a communication, a transmission request. This depends on the bandwidth. Then again, I have a computation, let's say, a logical time, which is on the web server between t2 and t3. I need some time to read on the server the request that has been performed by the client that just arrived. I have to decode this request, and I need to understand where I will find my content. So after this time, I can send a request to the disk of the server. The disk, of course, in this case I am thinking of an internal disk, so an internal hard disk inside the server. I send this request, which will have a time of milliseconds to get to the disk, and then here between T4 and T5 I have the reading time on the disk, because of course I need some time, depending on the type of the disk. If I have a hard disk of a rotating hard disk of the old generation, or if I have a SSD, for instance. But after reading the content, the disk sends the data back. At this point, the web server can read this data and prepare the HTTP response. Then I send this response. I have a time here which depends on the bandwidth and that I need to send back the response to the client. At T8 the client receives the response and can understand can read the HTTP response, pick the HTML content and show the web page to the final user here. Of course, this is a decomposition of all the times. In general, these times are in the simplest definition we can consider a latency which includes all the elaboration time, this and this, and a part which is this one size over throughput, which is the transmission time. Of course, I can have multiple requests to the same browser, and after some point we can perform a second HTTP request after some time, of course, where the user may elaborate what's happening and perform another click or perform another request. So in general, to make the architecture even more, let's say, detailed, even though we will add some more details in the future, at this point we have talked about these components. So we have my user, we have a browser that can be of many different types. Everything is kind of equivalent at this point. The browser has a simple rule, which is taking an URL, contact a web server and show content by using the HTTP standard protocol. The user interacts with the browser through a screen, keyboard, mouse, and any other mechanism for interaction, for providing input. In the browser, I have a so-called layout engine, which will be in charge of not using the HTTP protocol, but it just receives HTML and understands how to deal with it and show it to the user. And I have my internet network, which is the way the browser can communicate with the web server. Then the server can be of many different types, but in general the server has a single role, which is decoding a request and access to a file or an image which is stored in his file system, in his disks. If you need to buy some servers to get some infrastructure that you want to deploy, to get some software that you want to deploy, basically you buy a machine and then you install on it one type of web server. This is a statistic that is until December 2019, and we can see that at the very beginning Apache kind of was the most sold server technology, application server technology, is the blue line. Then we have other ones like Nginx, which is growing in popularity. We have Google and we have Microsoft, which is kind of, deceased by now. And the purple other line is many different technologies that are able to support HTTP. Recently there has been an explosion of technologies supporting HTTP, so there are many different ones, and selecting the proper web server technology is a part of design of web application engineering design, which is of course not part of this course. All the contents are based on HTML. HTML is a very simple language that allows to define the content of a web page by defining titles, by defining carriage returns, by defining any kind of content that should be provided inside a web page. If you are interested too, and I guess that many of you have a kind of information about HTML because of high school or any kind of personal interest, but in general there are many different informations provided by the official resource, which is W3 Schools, where there are many different tutorials to understand, if interested, how HTML works. Of course, this is not by any means part of this course. In this class, so we have seen the basic infrastructure of a web server and the communication with the client. In the next steps, we will see how to complicate this infrastructure by adding databases, for instance, cloud infrastructures, and making the server and the clients more complex. Thank you for watching.